before diving deep into my contributions, I would first Before diving deep into my contribution, I would first like to go through the introduction of the Libp2p. So, Libp2p is a modular networking framework library used by the peers to communicate in a distributed network. It comprises of various protocols, uh, uh, like the transport protocols, stream multiplexers, entity transversal, etc. And when compared with the Devp2p, it's more modular and interoperable. Devp2p is more concerned to the Ethereum's needs specifically. So it comprises of various components. Um, so the first component is transport. So like when a peer is connected to the internet, it basically shares and sends the bytes and bits to the via IP and TCP connection, which is like the combination of the internet protocol, which is responsible for the addressing and the sending data packets. And for the TCP, Transport Control Protocol, it's responsible for the sequencing of the data, like the order of the data packets that have been moved to the sender. It's been the same order as of the receiver. Moving on to the next, the handshake. So basically, when we have a TCP or IP connection, it's not secure. We need to secure the connection to transmit the data. So um, so the handshake is for the secure communication channel for the message exchanges. So it comprises the TLS protocol and the noise protocol. Um, Also, like the QIC is like one kind of transport which has the inbuilt encryption towards it. Yeah. So moving on to the next, the protocol negotiation. So during the selection of the multi-stream, uh, there are various multi-streams that the client can support, right? So we need to negotiate over one particular stream. So that's what the protocol negotiation is there. Like that was the negotiation of the protocol happens between the peers when they are, trying to have a connection between them. Multiplexing. So multiplexing is used for creating multiple virtual connections within a stream. So it's like a more scalable connection when the peer wants to send the multiple stream of messages over a network. So it comprises the MPlex and the YAMX. It's fast and efficient. Now I would like to move on to my contribution towards it. So like I built the full implementation of the TLS protocol. So I would like to give the introduction of the TLS protocol. So like TLS protocol is a secure layer communication used to encrypt data and authenticate peers. So how it works? So basically, during the handshake, peers authenticate the user by encoding their public host key into the X.509 certificate, and and so peers are not compiled to use their original public host key. They can use any arbitrary key types, and so like then the yeah. Peers use their host key along with the into the Libp2p public key extension. So Libp2p public key extension comprises of two parts, that is the signature and the host key. So for making the signature, the endpoints, what they do is they add on the string Libp2p TLS handshake along with uh, their host key, and it's signed by their private key. So like when it's been transferred to the other peer, the peer verifies that the signature is correct, and hence the successful handshake takes place. So here's the diagram that's showing that it sends the request of the same, and when the certificate is verified, the successful handshake takes place. So these are my most PRs that I contributed to the Nethermind's .NET Libp2p repo. Now moving on to the Perf protocol. So Perf protocol is basically used to measure how fast the Libp2p works. It's a benchmarking protocol, and it depends upon the two scenarios, like the throughput per second and also the handshakes per second. So yeah, so like it comprises of the two tests, update test and the download speed test. So what happens with the update speed test is that the client configures the server to uh, to respond with the 0 bytes. That means the client will send the data and the server doesn't need to send back the data. So once the predetermined bytes has been sent to the server, the client closes the connection. So it means so it closes the connections and the time is calculated for the same, and that's how the upload speed test has been calculated. Moving on to the download speed test. So download speed test, the client configures server to send over the n bytes, which is like the total bytes that will be downloaded from the server. So then like the server sends the data and and that's the time is calculated, and that's how the download speed test is conducted. So here's the screenshot showing the time seconds for the download speed test. It's like I haven't fully implemented it. It's in progress, and here's the link for the PR, and the mentor has suggested some changes, so like I need to work. It's in progress. Um, Moving on to the next. So the next thing that I implemented was the noise protocol feature addition. So as described earlier, that that during the protocol negotiation, we need to select the particular protocol for like the stream multiplexing, right? So so what happens is like we can fasten the process during the handshake itself. Like we can combine the handshake and the protocol negotiation as well. So it can be done with the help of the noise extensions. It's a particular feature of the noise. So like what happens is like so like there is the list of the protocols that the client supports, and there's a list of protocols that the server supports. And then when they're doing the handshake, so the for loop will be conducted through it, and like the first common protocol will be selected. And yeah, so here's the merged PR for the same. And thank you.
Thank you so much, Rose. Before we continue with the second half of this presentation, do we have questions on this part, on Rose? Anyone? Comments, questions? Okay, we can slowly move on then, guys. Come to please plug in. Yeah, because the story of this project is that it was started as a joint effort, but then it's split into these parts. So we have the C# part by Rose, and we continue with the Prysm implementation with Kira and Richa. So yeah, I promised you will see Richa on the stage again today, and here it is. So yeah, yeah, we need to switch to HDMI. There was a question for Rose. Can you estimate the time required to develop in a new language?
Could you more elaborate the question, like what's like the is it like the compilation time, or like to develop a new language, or what? Yeah, so I've been working for the past 3 months for this. Yeah, so I've been contributing to it from the past 3 months.
Yeah, thank you. And if we can switch to HDMI, we have the slides ready very well. Yeah. Is it yours? Just click on the slideshow. No, because is it from the computer? Yeah, okay. I see what's happening. It's mirrored. Yeah, and yeah, please use the keys to change. Okay. You need to you don't need to use the keyboard. Okay, go ahead, guys. Yeah.
All right. The project was initially started as a collaborated effort on like 3 fellows. Maxim, who did like most of the implementation part. He's not here today. And then Richa and me. So yeah, our part of the project was since like Libp2p is like used by pretty much every consensus clients. We basically were trying to eliminate the use of integral parts for Prysm. Since I think they announced like few months ago that they were gonna stop the maintenance of Libp2p. This project was basically trying to help Prysm team to enable this. It also enables elimination of the redundant components from the goal Libp2p, which are not really used, and like it just covers a lot of spaghetti code in the Prysm code base, and still not sacrifice on any kind of performance. And of course, like implementing this project would involve a deep understanding of Libp2p library.
Moving forward with the project structure. So what we did, we divided the project into several segments, since our main motivation was to remove the redundant parts of the Libp2p, to have the components of Libp2p which were basically used by the Prysm team. So we started with understanding how Libp2p was actually working and how Prysm was leveraging the Libp2p protocol. So we segregated the components, like what all Libp2p had and what all we actually needed for the Prysm. Then we filtered the elements, and there were several elements which could have been reused, as they were separate standalone components, and several components which were to be implemented or refactored. So we filtered out those, and then the next step was to implement the components in the package form in the Prysm code base itself, and then testing. Next, we had to integrate it with the Prysm code base to switch from the Libp2p protocol implementation to the in-house implementation. And next was to do the performance analysis and optimize the code for better performance, or at least the same performance as was with the Libp2p protocol. So how we move ahead. So first we worked on segregating the components. So as we can, we found out the main components which were actually used by Libp2p, Prysm in Libp2p. So there were some components for basic configuration of the Prysm basic configuration of Libp2p for Prysm, including the peer or the address configurations or the key configurations for cryptographic connections. Then the second one was main, which was basically linked with the config for actually making the connections or the starting configurations. Then there were TCP transports. So there were 2 transports which were, there are multiple transports protocols which were available in Libp2p, but the Prysm mainly uses the TCP and not the quick protocol. So we didn't, so we eliminated the quick transport and implemented the TCP one. Then there were TLS, which was used by quick transport again, so, and the TCP. So next, coming to the multiplexers, there were MPlex and YAMX implemented within Libp2p, but the Prysm only used the YAMX. So we eliminated the MPlex there, and then there were noise, which were just to be used as it is from the Libp2p. Then there were several more components: upgrader, peer store, the network, and the host. Apart from this, the connection gator and the connection manager, they were not to be used, or they were small segments which we just included it in the main or the config. And then talking about the gossip sub, these were the things which could be reused or eliminated. Next. Yeah, so how we implemented, so yeah, we have the components ready for the config, main, and the TCP transport, then the YAMLs, upgrader, and other peer store, network swarm, and the host. So gossip sub and the remaining components were either they were not to be used or they were to be integrated in the final protocol as it is from the Libp2p. So yeah, these are the main components that were to be implemented as we figured out in our first step. Next, we can move on how we are going to move ahead. So we have the individual components ready. The next step would be to integrate integrate the individual components, make the smaller code changes which are needed to actually test and connect the different individual components. The next would be testing and benchmarking and a complete protocol within the Prysm. And then finally, optimizing for better performances. Yeah, thank you.
Thank you very much, both of you. And we have questions for Kira, Richa, about the Prysm peer-to-peer Go library. Anyone? Okay, any comments, questions, last chance? There is, sorry. Yeah, this is the same one from before, okay, yeah. Anyway, please submit online questions if you are on the stream over there. Otherwise, we'll slowly move. Kira, you continue, right? And we have Caleb as well, yeah?